In this lesson, we're going to cover probability. In the video outline, we're going to look at 23.1, which is probability experiments, 23.2, which is theoretical probability, and 23.3, which is mutually exclusive events. So looking at probability experiments, this question says 80 students are asked to choose their favourite season. Part A, we need to complete the following two-way table. So with two-way tables, we complete a cell, and then that enables us to complete another one, and then we go around in a circle, essentially completing the table until we've filled in all of the numbers. So the first one I'm going to pick is this cell here, because we can work out what this is. If we've got 8 skiers, we don't know how many non-skiers there are, but there's 20 in total. This means that there will be 12 non-skiers. We've got spring 12, summer 18, autumn 7, winter 8. So if we add all of these up, we'll get the total in the total section. So 12 plus 18 plus 7 plus 8. This gives us 45. We can work out how many total skiers we have. There's a total of 45 non-skiers. The total altogether is 80. So 80 subtract 45 gives me 35. We can also work out the total number of skiers in the winter. 12 plus 8 gives me 20. You've got 20 plus 16 plus 20. So 20 plus 20 plus 16 gives me 56. And if we do 80 subtract 56, this is going to give me 24 here. Then we can work out how many skiers we have in summer. So 24 subtract 18, and this gives me 6, so we've got 6 there, and then 8 plus 6 plus some number plus 12 must equal 35. So 35 subtract 12, subtract 6, subtract 8, gives me 9. And then just to check, 9 plus 7 gives me 16. So that's part A done. Part B says a student is chosen at random. Calculate the probability a student prefers summer. So the summer section is this section here. So the total number of skiers in summer is 24. 24 out of the total sample size, which is 80. So 24 out of 80. We can simplify this to give us 12 over 40, dividing top and bottom by 2. We can go further, dividing top and bottom by 2 to get 6 over 20, and then go even further to give us 3 over 10, which is 0.3 as the probability. You can give it as a fraction, or you can give it as a decimal. Either way, you would get a mark for one of those. So that's part B done. Part C, calculate the probability a skier who prefers winter. So for part C, a skier who prefers winter. Now the winter section is this section here. We've got a total of 20 skiers in winter. It's 20 over the sample size, which is 80, which gives us 2 over 8, which is 1 over 4, which is equal to 0.25. So either the decimal or the fraction gets you the mark. And that's part C. The next question says you roll a biased dice 150 times. The table shows the outcome. Part A says if you roll a dice more than once, estimate the probability that it will land on a 1. So if it lands on a 1, the frequency is 50. So that means the relative frequency, which is also the probability, will be 50 out of the total sample size, which is 150. We can divide top and bottom by 10 to give us 5 over 15, and then divide top and bottom by 5 to get 1 over 3. So that's the first probability for rolling a 1. Rolling a 6 is 8, so we've got 8 out of the total sample size of 150. If we do 8 divided by 150, the simplified fraction is 4 over 75, dividing top and bottom by 2. So that would be the probability of rolling a 6, and then finally we've got a 2 or a 5. So when we've got two numbers, either a probability for one or the probability of another, we need to add the two probabilities together. So the probability of rolling a 2 is 24 out of our sample size of 150, plus the probability of rolling a 5, which is 26 over the sample size of 150. And if we add 24 plus 26, we get 50 over 150, which is equal to 5 over 15, which is equal to a third. So if you'd like to pause the video and have a go at this recall zone question, and then we'll come back and discuss the solutions. So this question says you throw a biased dice in the shape of a tetrahedron 100 times. The table shows the outcome of the experiment. You throw the dice again, find the probability that it will land on a 2 or a 3. So part A looks at a 2 or a 3. So when we've got two separate probabilities and we're trying to find either or, we need to add the two individual probabilities together. So the probability of rolling a 2 is 14 out of the sample size 100, plus probability of rolling a 3, which is 16 over 100. So if we add 14 and 16, because we've got a common denominator, we get 30 over 100, which can be simplified to give us 3 over 10, which is 0.3. Part B says, if you throw a dice 500 times, how many times would you expect it to land on 1? So if you roll the dice 100 times, you'd expect it to be a 1 48 times. 48 over 100 times. But this time, we need to multiply the denominator by 5, which means we need to multiply the numerator by 5. So 48 times 5 gives me 240 over 500. So if you throw the dice 500 times, how many times would you expect it to land on 1? 240 times.